Good evening. Welcome to the Certified Financial Planning Program's online session number 4, which is talking about time value of money. We had some technical difficulties when we did the class live on Wednesday, the 4th of the month, so 4th of February. So now we are back doing this. I'm sorry, we did on the 5th of February. This is the 6th, but you're going to get the entire recording again. Please remember that if you have not completed quizzes 1 and 2, it's your responsibility to complete quizzes 1 and 2. What we're looking for are the graded quizzes. Be aware of the fact that graded quiz number 1 you have 2 attempts at, so you should have a good score. After that, you will only have 1 attempt to do the quiz. So please make sure you do that. In addition, I mentioned that everyone was supposed to go back into the discussion board and introduce yourself, and then go to the discussion board and enter and answer the question, what is it about money that's important to you? And then it's your responsibility to go back and answer and comment on other students, at least 3 other students. You're not supposed to call other people and ask them a question and do a survey. Just do it through the discussion board. I will do the best I can to intermittently answer as many of your responses as possible. The purpose of this is to get an idea of asking open-ended questions, as well as making sure we build some sense of community for the online class. So, as always, I'm available via email at mktbear@yahoo.com or my voicemail 847-498-1840. I do try to answer voicemails and emails within 24 hours during the week. So let's begin time value of money. And I'm going to also, in addition to have the slide that's up on the screen, I'm going to identify what slide I'm on. One of the things you have to be aware of, ladies and gentlemen, is you have to do the problems. It's important that you take the time to do the problems and not just listen to the recording and not just assume that if you spend a few minutes in class, you're going to get the material. The comprehensive exam does ask you to be able to use the calculator for the basic time value of money, serial payments, annuity payments. You might have a net present value or internal rate of return calculation. You'll probably have some calculations from investment planning with different ratios. And in retirement planning, you'll also have some calculations to do. We are not requiring you to use the HP 10B2 or 10B2 Plus calculator at all. If you are comfortable with any other calculator, the 12C from Hewlett Packard or a TI calculator, as long as you can do the calculations, that's fine. The 43-question worksheet that is already in the content area, which I would think would be to your advantage to try to complete prior to the midterm. You will get the answers and the keystrokes for the 10B2 calculator. That's the only calculator we have the keystrokes for. But if you use any other calculator, you still have all of the answers. I don't expect you to complete all the questions and get them perfectly correct. I do expect you to try. If you do at least 80%, 85%, and send them, email it to me, I will make sure that prior to the midterm, you have all of the keystrokes and or answers depending on what calculator you're using. So, that being said, here is the first question. If hypothetically, and please understand this is a hypothetical question, the DePaul University Endowment Fund has authorized me to authorize you to receive $2 million income tax-free. $2 million income tax-free from the endowment fund. Or you can receive 2 cents that will double every day for 30 days. Some of you are aware of the answer, so if this is online and you're picking up the recording, what I want to do is think about what you think is the best answer. Take the guaranteed income tax-free money or the potential of income tax-free money on money that doubles. Well, when I've done this before, about anywhere from 50 to 80% of the class will end up saying, I want the guaranteed cash. But the true answer is $2 million income tax free sounds like a great deal until you do some compounding and realize that 2 cents doubling every day for 30 days ends up at around $10,700,000. So why am I asking the question? Well, because the magic of compounding is what we're talking about. As a financial planner, many times you're going to have people come to you and say, how much money do I need to retire? How long will it take my nest egg to double if I can earn 5%? How do I figure out how much I have to put away if I want to be able to save money for my children's education based upon an education inflation rate? All of these are questions you may be able to answer. Now, in all honesty, if you're using a financial planning software package, in many cases, you're going to have the software package do the work for you. But just like a CPA, you need to understand the process. You need to be able to do the work yourself. One of my big frustrations as an instructor here at DePaul and at the other universities I've taught at is people say, I can't do this. I don't have a background in finance, and therefore they drop the class after this session. Don't drop the class, because you can do this. I never took a finance class in college. I only started using the calculator as a financial planner. I sat down and I taught myself how to use this 10B2 calculator just using a workbook, and if I can do it, you can do it. In addition, ladies and gentlemen, we have a link up under content for this session that is a tutorial that you can link into and do an online tutorial for the HP 10B2. It has problems, it has the keystrokes. So if you have any other issue, that's now online and it's available for you. So let's go, and I'm now on slide number 2. You will be expected to be proficient using non-programmable financial function calculator to determine life insurance needs, retirement income needs, possibly investment performance, the internal rate of return, the net present value, standard deviation, and much more. The next group of slides that we have for tonight, about 54, 55 slides, gives you some of the basics for this class. You will get additional information in the pursuing classes. In addition, please go back to workbook unit 1 and 2 and make sure that you go through, once you have the calculator, go through those calculations so you're comfortable with them. I'm now turning to slide number 3. Please make sure you know how to set the calculator. So using the 10B2, you want to make sure that you can have the calculator set for 4 decimal places. Why 4? Because that appears to be the best number of decimal places for rounding for the exam. So it says here, make sure you turn your calculator on the on button, and then make sure you press the gold key, hit the display key, and then press the number 4. Slide number 4 will then say that this is what most problems are solved for on the comprehensive exam. Now, in all honesty, if you're using a different calculator, you might find that the rounding is a little bit different. But that's okay too, because even if the rounding is a little different, you're going to be close. Where you're going to have some other problems with rounding or being close, I'm going to explain when we're talking about begin mode and end mode, but we're not there yet. So if you're using a different calculator and just rounds a little differently, don't get hung up with it. Many important functions are just below the display box in the calculator. You should have your calculator in front of you as we're going through this program. I'm on slide 5. So it says N is for the number of compounding periods. N is for the number of compounding periods. The next box, starting from the left to the right, says IYR, and that is for your compounded interest rate percentage. Is it 3%, 4%, 3.5%? PV is present value, PMT is the payment, and FV is the future value. Now, are the key calculation or keys you're going to need. N is for number, IYR is for the interest rate, present value, the payment key, and the future value. You will also need to be able to use, under the future value key is the MAR key. And if you notice under that it says in gold, BEG for begin mode and END for end mode. Next to that, to the left, is net present value, and to the left of that is the internal rate of return. So let me just explain. You have to become comfortable with the calculator, and the only way to be doing that, ladies and gentlemen, is to practice it. So the default mode for this calculator is the end mode, because if you look at the screen, you should see at this moment a 0 with a decimal point or a dot, followed by 4 zeros. If you happen to see a 0 with a comma, in Europe they tend to use commas where we use decimal points, then please go and hit the gold shift key, and underneath, starting at the left, you have the on button, 0, and then a dot, and then under that in gold is a dot / comma. So if you have the comma, you hit the gold key and it should come back to the dot. The gold key is the shift key, which lets this calculator do more functions than what we can without the shift key. So if you look at the calculator again, you're going to see things in white, which means you haven't used the shift key. And then you're going to see words, letters, symbols in gold to match the shift key. To clear the calculator, you hit the shift key and the see all key. And I would advise everyone to get into the habit of clearing the calculator after every problem and before you start the next problem. Now, when you clear the calculator, as I'm going to say, that only clears the functions on the buttons above. The end function, the rate of return, the present value, the payment, and the future value. Other items you actually have to go and make changes, and if we need to do that, I will be giving you those pieces of instruction. Slide number 6, setting up your calculator for the number of compounded periods you need to use. The calculator is somewhat intuitive and will help you do a lot of things if you let it do that. However you want to use the calculator, be consistent. I'm going to go and use the slides and use the keystrokes, changing the compounding periods as indicated. I've had students in the past who always leave their calculator set at 1 compounding period and then divide the interest rate by the number of compounding periods and multiply the time, the end number, by the number of compounding periods, and they never make a change. I had a professor, friend of mine, who teaches finance and economics, who always leaves his calculator set that way. There's no right answer or wrong answer. You'll get the same answer. It's whatever you're most comfortable with, but be consistent. Make sure that when you're doing this, what you are doing is always doing it the same way. Always clear the calculator after your problem and before the next problem, and I'm saying that because of a couple reasons. When you're nervous taking an exam, if you're not comfortable with the calculator, you're going to find yourself not remembering. If you do it twice, you're going to know at least you did it once. You also are going to find that when you do the comprehensive exam, the problems aren't going to be all in the same order. Some of the problems are going to be question number 13, the next question where the problem might not be till 27, followed by 31, followed by 39, and then 45. And it's very frequent that they will change the compounding periods and whether it should be in the begin mode or the end mode in between problems. So if you haven't cleared your calculator and reset it the way you're supposed to, then you're automatically going to have a bad answer. And they will give you a bad answer as one of your options. So the number of compounding periods on slide number 6 says the default setting is monthly. So it's probably set for 12. So press the desired number of compounded periods, followed by the gold shift key, and then under the payment key, you'll see in gold, P/YR. So let's just change this to 4. So what does it say? Press the number 4, that's quarterly, the gold key, and then the payment key. And in your screen, it should say 4.0000. Now, to double check it, let's go and hit the gold key and the clear all key, and it should say 4 payments per year. So please make sure that we've just changed this to 4, and now it says 4 with a space, P_YR. That means 4 payments per year. While we're here, let's make it 2 payments per year. So hit the number 2, the gold bar, and again, the payment key, which is PYR, and then hit the gold key and the clear all key, and it should say 2 payments per year. It says here that default setting is 12 or monthly. So hit 12 gold payments per year, and again, it should say 12 payments per year. We are now going to the next slide, number 7. Alex deposits money into his investments that will compound at 6% semi-annually for 4 years. Well, it says you can multiply the time factor, you can divide the interest rate. That's by if you leave it set at 1 payment per year, or to establish the semi-annual compounding, press the number 2, press the gold shift key, and payment per year. And as I'm telling you to do this, I want you to make sure you do what's on the slide, and then to check yourself, hit the gold key and the clear or clear all key, and make sure it says 2 payments per year. Slide number 8. Jane owns preferred stock that pays a fixed quarterly rate of 3%. So now they want you to change this to a quarterly payment. Hit the number 4, the gold shift key, and the payment per year. Double check it. It should say payment per year, slide number 9. The slide says to clear the calculator before every problem. I'm also advising you to clear it after every problem. That way you always know where you want to be, and there's never a question about it. When you're under stress and you're not comfortable with the calculator or the math, you're going to forget something. My goal is to make sure that you have the tools you need. To fully clear the calculator, it says press the gold and the C key. To clear the last entry, you press the C key only. It's very important you remember that. So, I'm just to go C. When you press the gold C key, you're going to clear all the functions. But I also would then say you might still see it with a different time frame than you want. At least mine is that way. So I always double check it and make sure it's the way it's supposed to be. The default mode for this calculator is the end mode. So right now, all you should see on your screen is zeros and nothing else. It should not say begin or end. Slide number 10. Time value of money should not be confused with inflation. Time value of money just says if we get money today, it should have a value of buying power for today, hopefully, or a value today. If we are going to defer getting the money today, we really want to receive something greater. So part of the reason you need to understand the time value of money calculations is because you're going to be asked this. You're going to be asked if you know how long it will take my money to double. I have $300,000 in my retirement account. I need more money to retire. How long? What will that let me buy? How much income will that generate? Will that income be indexed for inflation? Or can we build that in? Now, one of the confusing things, I'm on slide 11, very confusing to many people, is the following. When is present value in the present? It says here, Doug bought 100 shares of stock 5 years ago at $50 a share, and he sells them today at $100 a share. Well, the problem is, if you think about what this is today you'd say is present value. But if you look up at the wording above it, it says present value is when your investment begins. Present value is when your investment begins. So what this really means is you have to think before you act. Whenever you're talking of an investment, when you start the investment, in this case, Doug purchased 100 shares of XYZ stock 5 years ago, that is what he started with. Now, when he sells it, that will be the future value, even if it says he sold it today. Please remember to read the questions carefully, and when you're talking of present value, it's always when the money was first invested. So let's go through this and see what the calculation says. It says Doug bought that 100 shares of stock at $50 a share. That's $5,000. So let's just go and hit the plus minus key, $5,000 present value, and you're going to see it says $5,000. Then hit $10,000 as the future value because it says he sold it after it doubled. Now, it further says on this PowerPoint slide number 11, you cannot input a positive present value and a positive future value. It's going to give you no solution. So what I'd like you to do is clear your calculator, hit 5,000 plus or minus present value, 10,000 plus or minus future value. Just for fun, let's hit 5N and 6 IYR. Oh, I'm sorry. I'm going too fast. Hit 5,000 plus or minus, clear your calculator please. 5,000 plus or minus present value, 10,000 plus or minus future value, hit 5N, and then hit IYR, and it's going to say no solution. So be aware that if you ever get no solution on a problem, it's because you probably entered for present value and future value plus minus, which means you spent the money. You're making it into a negative. Unless you're the U.S. government, you don't get to print more money and spend the same dollar a second time. So what we're doing here is we're saying you cannot have spent money in the present and in the future. There will come a point where you can spend money as a first installment payment as a present value and then have an ongoing payment. Both of those can be negative. But for present value and future value, they both cannot be negative. So I just want to make sure I'm going through this slow enough so that everybody can pick this up. The opportunity cost, slide number 12, represents the rate of return that could have been earned on an investment had the capital been available earlier. It's used in the present value calculation. Number 13, please clear your calculator. Please clear your calculator and have it set for 1 payment per year. Clear your calculator, please set it for 1 payment per year. Ivan will need $100,000 in 10 years to buy a vacation home. Presuming he can earn 5% annually on his investment, what is the amount of money he needs today in order to get there, if he has the amount of money available? So 1 payment per year is shifted because we're only making 1 payment. $10,000 becomes the future value. $100,000 becomes the future value because we're asking what we need in the future. 5 is the interest rate, so that's IYR. 10 is N for the number of compounding periods, and we hit present value. You'll notice that the present value has a negative in front of it because we're going to spend the money. Once we spend the money, you can't spend it a second time. So if you don't do this properly, and let's assume for a minute that you put 10,000 plus or minus the 10,000 as a future value, you're going to find that you're going to get a positive number under present value. And if you get that positive number under present value, you might have both a positive and a negative number on an exam question. You figure out which is the right one. Slide number 14. Rebecca purchased a zero coupon bond that will mature in 9 years at $1,000. Presuming Rebecca can earn an annual rate of return of 6%, ignoring commissions, what was Rebecca's cost to acquire the bond? Many times on an exam or quiz question, it's going to say either ignoring commissions or assuming $10, $50, $100 in commissions. They're going to tell you one way or the other. Clear your calculator. Make sure it's set for one payment per year. Enter $1,000 as your future value, 9 as your time frame, 6 as your interest rate, and if you hit present value, it should show minus $591.89. I'm going through this relatively slowly. You, ladies and gentlemen, can go through the problems. Please make sure you go to the problems in the textbook as well as the worksheet. Just to remind you, this worksheet will not be graded. It is checked in. You do as part of your course requirement, but it's not graded because the people that are familiar with the calculator and finance usually would get great grades. The people that weren't struggled, and then figure out the grades. I didn't think it was fair. So it is a non-graded assignment. This is the only worksheet that's required to be turned in. People have asked me if there's a worksheet for the 529 plans or for the FDIC insurance. There's some sample things up there for you to be aware of. You don't have to turn them in. The time value of money 43 quest problem situation is required. Capitalization of a number is my favorite thing to do when I'm talking to clients because it's very flexible and it's something I can use all the time. I am going to stop the recording and take a couple-minute break, and then I'm going to come back to the calculation in a second. Welcome back. What I'm trying to do is give you a few more breaks because I was asked to do that, so I'm going to be stopping recording from time to time. Capitalization of a number, as I said, is one of my favorite things to use when I'm talking to a client because it's very flexible and gives me a lot of advantages, a great deal of advantages that permits me to help a client and answer some questions. One of the things I will tell you is that when you're talking of capitalization of a number, it is not a time value of money problem. And many times you're going to get an answer saying where it's going to say no, not enough information provided to do the calculation. Well, if you are using a time value of money calculation, you are going to be given 3 variables asked to solve the 4th variable. Once in a while you might be given 4 variables and asked to solve. In other words, you might be given present value and a payment, interest rate, time period, and you're solving for the future value. But you're given at least 3 values asked to solve for 4. With capitalization of a number, you want to find out how much principal you need in that pot of gold in order to accomplish something, or you want to find out if I have a pot of gold and know how much interest I'm going to earn, what's my income going to be? It is not a time value of money calculation. You don't need all the variables. Please make sure that you look it up in the textbook if you have questions. I use capitalization of a number all the time to help people figure out an estimate of how much life insurance they need. I use it to help figure out how much income they're going to be able to generate if I know the interest rate on their nest egg. I use it to help them figure out how big their nest egg has to be. These are all approximations, but it's very important that you know how to use that. Let me give you an example. If I know up front that somebody has a mortgage of $350,000, car payment, additional debt on autos of $30,000, and if I know that they have credit card debt of $10,000, that is $390,000 of debt, not counting student loan debt. I'm just talking about credit card debt, car loans, your mortgage. If you have more debt, just add it in. If now someone says to me, Howard, I make $75,000 a year, how much life insurance do I really need? Well, let me ask this question. If you make $75,000 a year after you pay your income taxes and you pay your 401k plan and everything else, how much money do you save? Most people save very little. Many times people will say, I make $75,000 a year and my wife makes $100,000, but we still don't save a lot of money. Most Americans are four paychecks away from financial ruin because they don't have any nest egg or savings that they can rely on. So let's just use that $75,000 number. And let's assume that any income we generate is going to be taxable. I'm not going to get into the FICA tax or any of that. Let's just assume we need $75,000. Or assume you need $60,000. Yeah, let's just say 60. Okay, if I know that I can earn 6% and I need $60,000 a year of income, how much capital do I need? How much capital do I need? Well, here it says, Bucky the rodeo clown on slide 16, Bucky the rodeo clown wants to buy a bull. It will cost $500 per month for the upkeep of the bull. How much must he set aside in order to have the income to care for his bull, assuming he can earn 3% on his investment? And it says, clear your calculator, and then enter $6,000, because $500 a month times 12 is $6,000. Enter 6,000 and divide by 0.03, and you should get $200,000 in the display key. Now, that means that if you had $200,000 generating 3% income, you need $200,000. So let's go back to what I was saying about if I know how much income I need and I know the interest rate I can earn, how do I figure out my principal? In this case, take your $60,000, because I said let's assume $60,000 is your income after taxes, and it says divide it by 0.06, and that should be about $1 million. I hope everybody has that in their screen. So we need $1 million for income. We have $390,000 of debt, so we need about $1.4 to $1.5 million of life insurance. Simple calculation. It takes me a minute to do it. If someone says to me, Howard, I have $200,000 of income, of capital, and let's assume I can earn 5% on that, that's going to generate how much income? 5% of $200,000 is going to generate how much income? Take 200,000 times 0.05, and that's going to generate about $10,000 a year of income. I say, in addition to my Social Security, my wife's Social Security, and some money in my IRA or maybe a pension plan, I need $25,000 or $30,000 of income. How do I figure it out? At the same interest rate. Well, I know that the first $200,000 is generating $10,000 of income, so now I know I need $600,000 to generate $30,000 of income. Capitalization of a number is an easy thing to do. On the comprehensive exam, I've never seen questions where they said divide by 3.6. It's always been a whole number, from what I've been told. So capitalization of a number, not to be confused with time value of money, important thing for you to be aware of, something you should definitely be using. Now, it further says on slide 17, when inflation and the interest rate are given, what do? This is an approximation. Capitalization of a number is not precise. It's an approximation. So here it's saying just net it out, subtract it out, and move on. So in the event we're talking of this on slide number 18, there's two things here on slide number 18. Number one, you might get a question that politically offends you, where in this one talking about adding to a gun collection. It might offend you. Don't get hung up on that. Some of what they're doing on the exam is they're deliberately trying to offend you, upset you or something, so you don't, I don't know how to phrase it, so that they try to mess up your mind. So let's read this question. Focus on the question and the problem, not on your political or moral beliefs. Sherman, a retired general, wants to have $5,000 in annual income each year to add to his collection of rare firearms. He can earn an after-tax rate of return of 3%. Assumed inflation will be 1%. So what it's showing here is clear your calculator, take your $5,000 that he needs to build each year. He wants to spend $5,000. He doesn't want to spend down the capital. He wants the capital to be there all the time. So 5,000. Why did it say divide by 2? Because 3% is what he's earning, 1% is inflation, so it's going to say 0.02. You divide the 5,000, divide by 0.02, it equals, and it should say 250,000. Now let's assume for a minute we can earn 6% on our investment, and the inflation is still at 1%. So let's go and say if we can earn 6, inflation's 1, we're netting out 5. $5,000 divided by 0.05, that means we only need $100,000 as opposed to $250,000. Slide number 19. The future value is what will be at the end of your investment. Just like the present value is always going to be at the beginning, the future value is always going to be at the end. And again, people get very confused about this when they're looking at one important factor, how this problem is worded, because many times it's confusing to them. The future value is the end of an investment, such as when I reach my goal for my honeymoon, my second honeymoon, my 25th wedding anniversary, when my kids go to college, or when I retire. The present value is at the beginning. So your calculator, on the screen it should say, Hank has $5,000 to invest today in a security that will provide a total annual return of 9%. What's it going to be worth in 8 years? So $5,000 plus or minus present value because you're spending the money, 9 IYR, 8 is N, hit the future value, and it should show $9,962.81. Now, if you look at your calculator screen and you set it for 4 decimal places, it's going to say 0.8132, you round down. If it's going to say 0.8179, you round up. However, so let's assume for a minute that the closest answer is $9,961 or $63, and there's no other close answer. Go with the closest answer. It's just a rounding issue. If, on the other hand, there's something that's really close, it might be that you didn't know if the calculator should have been set in the end mode, begin mode, or whatever. But if it's only one item that's really close, assume that it's a rounding issue. I've already discussed the plus minus key, which permits you to have a negative number. This is slide number 20. You use it frequently when you're doing the problem, when you spend the money. You're probably only going to be using the plus minus key on initially on present value or payment, but be aware it's when you spend the money. So it says the client makes a payment, makes a deposit, the money's spent. That's why it's plus minus. It's become negative. Slide number 21 is a problem which says that we're spending some money. Brian paid $6 per share to purchase 2,000 shares of a 5% preferred stock. Presuming the dividend is paid quarterly and reinvested at the same rate, what will his investment be worth in 12 years? Well, let's figure it out. Clear your calculator. Why does it say 4 gold key or shift key payment per year? Because the problem says the dividend is paid quarterly. So 4 gold shift key payment per year, we now have the calculator set quarterly. $12,000 plus or minus, we're spending the money is the present value. 5 is IYR. 12 is the number of years, the shift key, times payment per year because it's quarterly. That automatically lets the calculator do it. Your future value should end up being $21,784.26. I did do something wrong. Hold on a second. I did. your favorite instructor hit the wrong key. So let me do it again. 12,000 plus or minus present value IYR. If you hit the gold shift key times and under the N payment per year, you should see 144. And then if you hit future value, something's wrong. Oh, I know what I did wrong. Okay, start the problem again, please. I hit the wrong keys. 4 shift payment per year, 12,000 plus or minus is present value, 5 is your interest rate, 12 payment per year. It should say 48 in the screen, and then hit future value, and it should say 21,784. I hit the wrong key, and then I hit it a second time the same way. So for slide 21, if you do this properly, you start with 4 as your compounding period. Since it's investment quarterly, you're going to have 48 compounding periods. That's why you need to make sure that you use the 12 gold or shift key times payment per year. It's under the N, not periods per year under the payment. Slide number 22. This is asking you to solve for the interest rate. Solve for the interest rate. Darryl deposits $3,000 into a certificate of deposit 3 years ago. If his account had grown to $3,750, what was his interest rate? Please clear your calculator. It should be set for 1 payment per year, just to play safe. So $3,000 plus or minus present value. $3,750 without a plus or minus is future value, because that's what you're going to receive. 3 is the number of time periods. And then if you hit the IYR, it should say 7.72. Now, ladies and gentlemen, the problem answer might say 7.72. It might say 8%. It might say 7.75. It might say 7.0. If you have only one option, go with the closest option. If you have more than one option and they're real close, redo the calculation. Okay? I am now on slide 23 for tonight. Gene has $3,000 to invest and wants to accumulate $5,500 in 4 years. If Gene can invest quarterly, compounded quarterly, what's your rate of return in order to reach your goal? What does she have to earn? It's 4 gold payment per year under the payment. You should see a 4 in the screen. $3,000 we're spending the money. It's plus or minus present value. $5,500 is our goal, which is the future value. Now it says 4 gold shift key under N, which is payment per year. It's a 16. IYR should be at 15.4441. So you notice this slide says 4 shift N. The previous slide said 4 shift times payment per year. The same key. I set up this way for a reason, just so you don't get all confused depending on what you're looking at. Slide number 24. Dan has $2,500 to invest in an investment paying 6% interest. If Dan needs $4,400 to pay for a trip to Europe, not a very fancy trip, he must be going to some youth hospitals, how long will it take him to commit the money? Clear your calculator. Make sure it's set for 1 payment per year. He has $2,500 in cash, plus or minus his present value. $4,400 is what his future value wants to be. He can earn 6%. We wonder how long it's going to be. Hit N. It's going to say 9.7018. However, here in bold letters it says equals 10 years. Again, I don't know how they're going to write the test question. It could be very precise, meaning 9.70. It could be 10 years, or it might end up being 9.75. It would probably either be 9.70 or 10 years, but just be aware you go with the closest correct answer. Number 25, Marty invests $1,000 in a newly issued bond earning 5% compounded semi-annually. Marty needs $2,750 to buy a motorcycle. Again, it's not the most expensive motorcycle. How many years will it take him to accumulate the money needed? When you read the problems, whether it's a mortgage amortization problem or one of these, don't get hung up on well, who can buy a motorcycle for $2,700? Get hung up on the process. So here, gold, shift key payment per year. Tested, it should say 2 payments per year. Hit $1,000, because that's what we're going to spend, plus or minus is the present value. We know we need $2,750 somewhere in the future. We know we can earn 5%. What we don't know is how long it's going to take us to earn it. So now we should have 5% in the screen, hit N, and it says 40 time periods. Well, now we have to remember to divide by 2. Why? Because it's compounded semi-annually, so that's 40 compounding periods. But we really want to know how many years. A little confusing. That's why I'm going over it. But again, I don't know how they're going to write the question on your comprehensive. So if this is what you get, be aware of it. I'll do a couple more slides, and then I'm going to take another short break. I'm going to take a break right now. Welcome back. The rule of 72, like compound the capitalization of a number, is, again, something I use all the time. Because people will say, if I have so much money, can earn so much, how long will it take my money to double or triple? The rule of 72 is a good shorthand estimate of how long it takes money to double if you know the interest rate. If you know the interest rate. One of the problems with the rule of 72 is if you know the interest rate, I really hope you remember the multiplication tables that you learned when you were in 5th, 6th, or 7th grade. And you need to remember 72 is the number you divide things into. I'm not using the mathematical terms because people tend to forget them. 72, if you know what the interest rate is, you will divide 72 by that interest rate. Now, and the reason you want to do that is, if you know how to use this, rule of 72, it's faster than doing the problem. Let me give you an example. Let's assume we have $5,000 plus or minus present value. Let's assume we're going to earn 0.06 on our investment. That's the rate of return. Let's assume we know that the $5,000 we want at some point in the future to be $10,000. So that's the future value. We don't know how long it's going to take. So if we press the button, and for N, we see it's 11.8957 years. That's how long it takes to double. On the other hand, if I could turn around and say 72 divided by 6, that gives me 12 years. That took me 5 seconds, 10 seconds, as opposed to a time value of money calculation that may have taken a full minute, minute and a half. So someone's going to say, why is this so important? Here's why it's important. Number one, you're taking a comprehensive exam. You only have so many minutes to do the exam. Once you do the exam or get into the exam, you don't get to start and stop. It is a timed exam for the period of time they give you. It could be 3 hours. It could be 4 hours. It could be 6 hours. Whatever they give you and what they're going to be going to is a comprehensive exam over a 6-hour session, which will probably be broken down into 2 3-hour sessions. If every question is you're given 1 minute You're given 90 seconds. Some of the questions might take longer to do, but if you know the rule of 72, you can do that in 5 seconds. You've now saved yourself a lot of time that you can use towards some other questions. What you need to remember under the rule of 72 is some basic information. Number one, as an estimate, I'm now on slide 27. As an estimate, how long is it going to take money to double? So what you really should do is take a piece of paper and say, at 12%, 11%, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Well, obviously, if you're earning 1%, it's going to take 72 years to double. 2% is going to take 36 years. 3% will take about 24 years. So what you want to do is be able to do this in your head. I really can tell you, I have never seen a problem that says we're earning 3.5% using the rule of 72. How long will it take my money to double? It's always been a whole number. 12%, 10%, 8%, whatever. Obviously, if you can earn 8%, it's going to take 9 years. If you earn 9%, it's going to take 8 years. If you earn 10%, it's 7.2 years. The problem may say 7.2 years or 7 years. So be aware of that. It also helps to know that if you're earning less than 1%, let's say you're earning 0.25%. Well, 72 divided by 0.025 is like 288 years. But we'll be long dead by 288 years. But why am I saying that? Because current interest rates are there now, so people might make a joke about it. The rule of 72 is a wonderful, wonderful thing. And it helps a lot of people figure out what to do in a shorthand. What if somebody says, I have $225,000 in my nest egg. How long will it take me, my money to triple in the event I can earn 3%, 5%, 9%, whatever it is? Then as opposed to the rule of 72, it's the rule of 116. As opposed to the rule of 72, it's the rule of 116. One of the next problems that is frequently tested would be the value of an annuity. Now, Henry expects to receive payments of $1,500 at the end of each of the next 4 years. If his opportunity cost is 3%, what is his annuity worth? When you're talking of an annuity, unlike capitalization of a number, you're spending down the money. You're spending down the money. So there's a way to do it. So clear your calculator, have it set for one payment per year, enter $1,500 as a payment. Now, there's no plus or minus because he's expecting to receive the payment. He's not going to make the payment. It says he's going to receive it. Okay? It then says he can earn 3%. That becomes the interest rate. It then says he was going to get it at the end of each of the next 4 years. We're solving for present value, so when you hit that, it should have a negative 5575.65. This is the present value of an annuity. You'll notice that the payment, or the present value, not the payment, the present value is a negative because you spent the money. It's going to be given to Henry over 4 years as a payment. Key thing. The default mode of your calculator is the N mode. And nothing appears in the display. Clear your calculator, hit the gold key and the clear all key. Make sure it's set to one payment per year. To do that, make sure it's one gold payment per year. Then hit it again. Make sure everything says 0. You should see nothing in the identification box. To set the begin mode, press the gold key, and then under the MAR key it says begin. So if you set it to the begin mode, that means the payments and all your calculations are going to be done in the beginning. To remove it, hit the gold key and the end mode, and now it is the same way. So let's just do one problem. Okay, I'm going to hold on a minute. Begin mode is mainly relevant when payments are going to be received. I'm going to come back to this in a minute. And when are the payments received? Well, on an annuity due problem, payments are at the beginning. On an ordinary annuity, the word annuity is at the end. So this is a shorthand for you to help figure out when the payments are being made. And now on slide 33, ordinary annuity or payments made at the end would be mortgage note payments, auto loan payments, quarterly dividends, semi-annual interest. Annuity due, the payments are made at the beginning, such as insurance premiums you paid in advance and lease payments. Now, let's assume for a minute, and I'm going to write this down as I do this problem. Let's assume that we have the calculator set in the end mode. We have $100,000. That's going to be what? Well, let's just say the $100,000 is present value. You can earn 6%. We want it to last for 12 years. We need to know what the payment should be to have that $100,000 in 12 years. What do you get? You should be making an $11,000 payment in each of the 12 years. Now, let's assume that we set it for the begin mode. Let's do the same problem. Calculator set for one payment per year. $100,000 is the present value. 12 years is N. I think I said 6% is IYR. The payments are 6% IYR, 12 is N, 100,000 is present value. The payment should be almost the same, but because it's in begin mode, the payment's a little bit less. Let's move over to slide 35. Paul invests $5,000 into an IRA at the beginning of each of the next 8 years. So you make sure your calculator is set for the begin mode. If Paul can earn an annual rate of 8% on his investments, what will it be worth in 8 years? I'm going to take a deep breath, have a little bit of water, use the problem. You'll notice that the payment is what's being spent. He's spending it on his IRA. That's why it's plus minus, negative. It's been spent. 8 is the number of years. 8 is also the interest rate. So it should come out to $57,437. What does this really mean? It means that if he has a consistent 8% return, he's doing very, very well. The world doesn't only give you consistent 8% returns. So maybe you have to think about it a little differently, but for the problem, that's what it's asking. This is a really, really tricky problem. It's a two-step problem. I want you to come back to it and do it because this is about as complicated as the problem is going to be. We're on slide 37. And what does it say? It says Chester will have to make payments of $8,000 per year 6 years from now. That means he doesn't have to make the payments now. He has to start making them in 6 years. He will make 5 annual payments at the beginning, that start at the beginning of the 6th year. Chester feels that he can earn 9% after-tax rate of return. How much does Chester need to invest today in order to fund the payment? Now, in bold letters it says, because the payments start at the beginning of the 6th year, the compounding period is only 5. That's why this is a tricky, tricky problem, because it says he's going to have to make payments 6 years from now, and it says he's going to have to make 5 annual payments at the beginning of the 6th year. So if you first read the problem without reading it carefully, you're going to assume everything is 6 is the time frame and you're going to be wrong. So that's why this is tricky, and ladies and gentlemen, this is what they will do on a comprehensive exam. So let's do the problem together. Make sure your calculator is cleared. Put $8,000 plus or minus is the payment. The interest rate is 9%. How do we know that? Because it says so. Time periods we need this is in 5 years, because it says we're going to have to start making the payments at the beginning of the 6th year. The present value is $33,917.75. Then we have to go to step 2. Now we have to add in $33,917.75 is our future value. Again, we're still earning 9%. Again, we're still going to talk about it in 5 years. And then we hit the present value, and we should have just about $22,044. So what I want you to do is make sure you understand the process. $8,000 plus or minus payment per year. 9 is the interest rate. 5 is the time bracket. The present value ends up being $33,917. The present value here becomes the future value of the next problem. Clear the calculator. $33,917.75 is now the future value. 9 is the IYR. 5 is the number of years. We're solving for present value, which comes out to $22,044. Present value, which is a negative number. I'm sorry, which is not a negative. It is a negative number because that's where we're starting. It says, what must he invest today to fund that future need? So it actually should be equals negative 22,000, okay? Peter wishes to purchase a sports car for $34,000 and can finance the payment at 2.5% compounded annually over 4 years. Determine what amount of payment he will make at the end of the year. 1 gold payment per year, $34,000 is because that's what he's going to need at the present value when he wants to purchase a car. 2.5% is the interest. 4 is the time period it payment. It should show. What does it show? What does it show? 34,000 as your present value, 2.5 as your interest rate, 4 is N, you're solving for payment. It should show minus $9,037.80, or actually 8.8078. They really just gave you this as an answer. It should have been rounded the other way, but it didn't. What if the question asked what would be the monthly payment? Well, you can either divide this number by 12, or what else could you do? What else could you do? You could take the 34,000 as your present value, 2.5% interest rate per year. 4 is the right answer. It should be 48. Well, 4 would be the payment if you're making it once a year, and maybe it should be 48 because you're going to be making it every single month, and then hit the payment key. What do you get? Well, you get no solution. Why? Well, let's do it again because we left out a step, and I left it out deliberately. 34,000 present value, 2.5% is interest rate per year, 4 is N. Now we know that what the answer is going to be, $9,037.80. Is 4 the right? Is 4N the correct answer? Well, if it's asking for monthly, maybe it should be 48 is N, 2.5 divided by 12 would be interest rate. 34,000 would be present value. We're still solving for payment. Now it's $700 a month. 708 times 12 comes out to what I hope is the right answer. 708 times 12. It's not. 34,000 is the present value. 0.5 interest. Well, the easy way I would do it is just take that 9037 divided by 12. But the calculator could, and you get 753. The calculator would come up close if you did it another way. Slide 39. Melissa borrows $15,000 to buy an antique dining room set. She must be paid a loan over the next 4 years at 3% interest rate. She wants to know how much to pay. Fill your calculator, set it, since this is going to be monthly, set it for 12 payments per year. Do the problem, please. So this is walking you through doing the entire problem, and you should have the right payment. Next problem, slide 40. Dad needs to accumulate $130,000 in 10 years for his daughter's education. Dad might ask you this question. He can earn 5% compounded monthly on his investments. What must Dad invest today, or at the beginning of each month, over the next 12 or 10 years that he reach his goal? The first thing we need to do is make sure that the calculator is cleared, and then set it for the begin mode. Then we want to set for 12 payments per year. Then we have $130,000 that Dad needs as your future value. Then we know he can earn 5% as the interest rate. We know he wants to find out in 10 years. We need to know what that payment's going to be. We make sure you come up with $8,833.71. Once again, have it set at the begin mode. $130,000 is the future value. 5 is your interest rate. Since we have this thing set, it's going to be 10 gold times payments per year. It is going to be monthly times 10 years. And we're trying to find out again what's the payment. It should be $833.71. Slide number 41. What frequently will happen is your client's going to have some money. You know what? I'm going to take another quick couple-minute break in case somebody wants to take a quick break. Welcome back. We are starting on slide number 41. Sometimes your clients have money they're going to put in as a lump sum, and they're going to have money that they want to add on a regular basis. It could be rolling over from their IRA, 401k, but we need to make sure we have things set the way they need to be set. The question will tell you if it should be in begin mode or end mode. The question will tell you how many time frames you need. So let's look at a problem on slide 42 and see where we go. Kevin is 49 years of age. He owns a growth mutual fund with a current market value of $8,000 and wishes to add to it by dollar cost averaging into the fund $1,000 per year until he retires in 17 years at the age of 66. Presuming the fund distributes no dividends or capital gains, it's going to earn 9% per year. What will the account be worth when he retires? Here we have a present value number and a payment. This is where you can use the plus minus key twice because you're spending the money twice. First, you're spending the money as a, what you've accumulated, then you're spending it as an ongoing payment. That's different than using the plus minus key on the present value and on the future value. So, through your calculator, make sure it's set for one payment per year because he said he's going to do that, one payment per year. Now we put in $8,000 plus or minus is our present value because he already has the $8,000. We're going to put in $1,000 plus or minus as a payment because he's going to spend the money each year. He's going to earn 9% interest, and he needs it for 17 years, and that's N. So now we've put in 1, 2, 3, 4 items we're solving for the fifth. As I said to you, most of the time we're going to be given 3 items and asked to solve for the fourth one. Here you're given 4 items, asked to solve for the fifth one. Then hit future value, and you should have 71,594.77 or 71,595. Important that you remember you might get a problem where you already have the money on deposit, and then you're asked to add to it. Slide number 43. This is a formula you're going to have to memorize. There's no way around it. I can't do anything to help you. I'm going to try to help you with a couple hints. I don't want to use mathematical terms because people tend to forget the exact term. So let's discuss this a little differently. Number 1, the formula says we want to be very, very, very precise when we're discussing inflation. This is not like capitalization of a number. We're being precise. I told this story earlier. I'm going to tell it again. Back in the days of Napoleon, we didn't have GPS systems. They developed what they thought was a calibrated meter rod that is on display, I believe, in the French or the Museum of something in Paris. The meter rod was so Napoleon could make sure that he knew where every place in Europe was to the center to Paris, which he determined was the center of his empire. So he sent out groups of people in every direction to every major city and area, and they would measure it. We didn't have GPSs. They didn't have sophisticated items, so they took the meter rod and they literally rolled it over and rolled it over and rolled it over, and they had as they needed it. They had some mathematicians so they could figure out how to go over a mountain, how to go over a river. Sometimes there was a group of them that got beaten up or robbed. Sometimes there was 1 or 2 groups that spent a year or 2 in a monastery because there was a civil war going on. So they were measuring everything. Fast forward to, I don't remember, it was 1999 or 2001, it doesn't matter. We now had satellites and GPS systems. Things were much more precise. And they said, gee, based upon what we know now with the satellites and GPS systems, we know that from the westernmost point of Europe to downtown Paris, to wherever the castle was, is wrong. Because by taking this little meter rod and flipping it over and over and over millions of times, we're about 2 miles into the Atlantic Ocean. What did it tell us? It should tell us you can be close, but you don't get the cigar for winning because you're off a little bit. So if we're using an estimate on capitalization of a number, then we can use an estimate. But if we need to be precise and we want to know exactly what the rate of return is going to be, so we know how much money we actually need, we need to be more precise. We need this formula. Now, it says inflation reflects the erosion on the purchasing power of investment. Well, just think about this. When you were younger, you probably went to a movie and it may have cost $3.50, $4.50, $5 to go Saturday afternoon to see a movie. Now it's $7.50, $8.50, $10. When you were younger, you or your parents may have been spending $1.25 or $1.50 for a gallon of gasoline, and now it's $3.50 to $5. If you're real lucky, it might be under $3. That's the erosion of purchasing power, and it happens little by little. Whoops. Now, if I was to say that we can earn 9% on our money, and we know we can earn it year after year, and inflation is going to be 3%, I could say, well, why don't we just use 6% as a net return? Because we're going to be close. So please take your calculator and please enter, we're going to make it into a decimal, 1 plus 0.09. So I'm sorry, 1.09 divided by 1.03, and you should get 105.8252. The formula then says minus 1 times 100, and you should end up with what? 1.09 divided by 1.03 minus 1 times 100. You should end up with 5.8252. 5.8252. That's close to 6%. You could round it to 6%, but you're going to have an answer that's not going to be precise. When do you need to know that you need to use this formula? When the question is asking for buying power, purchasing power, in terms of real dollars, in terms of today's dollars, in terms of inflation-adjusted dollars, those are the keys to let you know that you need to use this formula. Sometimes, in my lifetime, inflation was actually higher than the interest rate people were earning. So if you think that you always put the higher number as the divisor, the number you're being divided into, you're going to be wrong. Please write down the following words. Step on inflation. Step on inflation. So even if your inflation number is higher, inflation's at 15%, you're only earning 12% on your money, you may come up with a negative rate of return, but at least you're coming up with the right answer. Step on inflation. Returning the inflation number, the gross earned number divided by the inflation number, coming up with a precise answer. So let's assume, and let's redo it together now. Let's assume you're earning 7%. So it's 1.07 divided by 1.03. 1.07 divided by 1.03. 1.07 divided by 1.03. Minus 1, because we're taking away the 1, times 100, because we're making it into a decimal, is 3.8835. Again, that's close to 4%, but it's not exactly precise. If you look at the problems on your worksheet, when it tells you to use purchase, and you need to maintain buying power, purchasing power, real money in terms of inflation-adjusted dollars, in terms of today's dollars, they're going to tell you what you need to know. If they're just asking a different question, you may not need the formula, so be aware of that. Michael can earn an after-tax rate of return of 7%. He assumes inflation is 3%. That's where we come up with the formula. So on slide 44, it's giving you a precise formula. In the textbook, there's some problems using the formula. The worksheet has problems needing the formula or not needing the formula. Read it carefully. The tutorial online has some of the problems also. Sometimes the amount of dollars saved increases year after year to maintain the constant value of inflation. And this is a little tricky because you have to read this carefully. I'm moving over a slide from 45 to 46. Fred needs an additional $200,000 to fund his retirement, which begins in 14 years. He assumes inflation will average 3%. He can earn an after-tax rate of return of 7%. on his chosen investment. Calculate the first two of a series of payments. Now, we used to have a workbook which said calculate 12 series of payments. So if you want to get practice with it, do it. But on a comprehensive exam, you'll probably only have to be asked 2 or 3 series of payments. You're going to notice here that you're using the inflation-adjusted rate of return formula first, then you have to reinflate the money. Why? Because it's not saying he's going to be doing it at the beginning of he says the payments to fund retirement was going to begin in 14 years. He assumes inflation will average 3% and he can earn 7%. What is the first two of a series of payments? It doesn't say that the payments are at the beginning of the year. It doesn't matter. The payments may be at the end of the year. If it doesn't say the payments are going to be made at the beginning of the year, you need to do the problem this way. So first you're doing the interest-adjusted rate of return formula. You're going to come up with 3.8835. Then you come up with an answer. So the answer on the payment is $11,021.46. That will be an answer on your question, which says, at the end of the year, how much are you going to deposit? But you have to reinflate it at that 3%, so it's 1.03 times the 11,021.46 to come up with the next number. Please get comfortable by doing this. It's very, very important you know how to do it. The next couple slides are a little more difficult in nature because we're talking about uneven cash flows. You don't always earn the same amount of money on an investment, so you might have uneven cash flows. I'm on slide 47. Slide 47 says, what if you're invested in common stock? Does it always pay the same dividend? Does the dividend go higher or lower? Does real estate always guarantee you a 5 or 6, 7% rate of return? What if you have to spend money to repair something, or if somebody gives you an increase in cash flow, or you have to make another investment? This slide number 48 explains the keystrokes and what they mean. Go back to your calculator, and you will notice that there's a CFJ button in white in the middle of the calculator, 2 buttons above the 8. That stands for the frequency or cash flow. Next to that button, there is a button called NJ, which is on the same button if you hit the gold key, which talks about the frequency of the cash flow. The internal rate of return is where? Where is the internal rate of return? Well, that's going to be IRR. And the IRR is above the CFJ on the cost button, but you need to hit the gold key for net present value. And right next to that is the net present value. Again, you hit the gold key. So let's go to the next slide, number 49, and read the problem. Ron purchases a tract of land for $30,000. 1 year following the purchase, he improves it for 6. The year after that, he improves it again for 7. At the end of the 3rd year, the tract is leased to a tenant who immediately pays $8,000 for that year, $8,500 for the 4th year. If Ron sells the real estate for $4,500 at the end of the 5th year, what's his rate of return? Well, here's how you do the problem. And I will tell you that this is an internal rate of return, and they usually have one kind of this problem on the comprehensive exam. The CFJ key, if you go back to the previous slide, previous 2 slides, it says the cash flow. CFJ stands for cash flow. So here, 30,000 plus or minus, we spent the money, we bought the piece of property, CFJ. 6,000, we made some improvements, we spent the money, CFJ. 7,000, we made more improvements with the sewers, we spent the money, CFJ. Then we turned around and we received 8,000 of income 1 year, 8,000 the next year. So we have 5 periods. So far we should have 5 periods of CFJ. And now we spend the money. Now we sell the property. So then, after you put in 45,000 CFJ, but you'll notice the first three items we spent, the next three items we received the money, we don't put plus or minus. We hit the gold shift key, then we hit the IRR key, which is under the CST, and we should get 9.03. That's one rate of return. These are a little more complicated. You need to do the homework in order to make sure you understand how to do the problem. There will be a problem on the midterm, asking for internal rate of return and or net present value. There's a quiz question, and there's usually at least one of each of these on the comprehensive. This one is saying a little differently. Please read, let's read it together. Jay is considering an investment in a new business. He requires for an investment carrying a level of risk an average compounded rate of return of 10%. He doesn't want to invest unless he's getting 10%. Almost sounds like the Sharks on that NBC station. He expects to keep this investment for 3 years and then sell it for $375,000. He anticipates that he's going to spend $20,000 at the end of the first year, $17,000 at the end of the second year, $6,000 at the end of the third year. He further expects to get a distribution or income of $9,500 and $14,000 at the end of the first and second year. What should he pay for? This is a little more complicated because you have to do some math in your head to figure it out. Zero CFJ is when he's going to make the investment. That's what we have to figure out what he should pay for it. $10,500 plus or minus, because he says he's expecting to spend $10,500. I'm sorry, he's anticipating expenses of $20,000 at the end of the first year, $17,500 at the end of the second year, and $6,000 at the end of the third. He expects to get $9,500 in distribution at the end of the first. So $20,000 minus $9,500 is where you get the $10,500. He expects and $14,000 at the end of the second. He's going to spend $17,000 at the end of the second. He's going to get in $14,000. It's going to cost him $3,000. That's why it's plus or minus. He says he's going to get $6,000 at the end of the third year, and he expects to sell the property for $375,000. $6,000 minus $375,000 is $369,000. He wants a 10% rate of return, hit the gold key, and net present value. On the worksheet and in the textbook, there are net present value, internal rate of return problems. Please make sure you look at them. The NG key can be preceded by the gold shift key. This is something you should, slide number 51, do on your own. It's just that sometimes you can use the keys and not have to enter all of the data. However, I'm going to tell you, if you get past, I believe it's 14 periods, you're still going to need the data. So you go and do this last 3 or 4 on your own and make sure you study it. I can't pull up the slides from week 1 and week 2, but go back and make sure you do the math provisions on those problems. Net present value, if it's positive, you want to make the investment. I'm on slide 52. If it's negative, you don't want to make the investment. It's asking, should you make the investment based upon the previous slide. Amortization. I had 2 amortization problems on my comprehensive exam. The first one was where it gave you borrowed so much money, your monthly payment, your interest rate was so much, it was for 30 years, your monthly payment was so much, how much interest did you pay on the period of the loan? In round numbers, you borrowed $200,000. By the time you multiplied the payment by 360, you came up with whatever the number was, you subtracted the 2, that's what your interest was. If you don't get a problem like that, you're going to probably get a problem on slide 54 that's going to have to require you to do the math. Sam and Mary Ann plan to purchase a 3-bedroom home for $350,000. They've accumulated the funds to make a 20% down payment. So 350 minus 20% is 70,000. They're not giving you 70,000. They're not telling you whatever. You better be able to figure it out that you're only borrowing 280. They will finance the remainder with a 30-year fixed rate mortgage at 4.25%. Now, step one, clear the calculator. 12 payments per year. So make sure it's 12 payments per year. 280,000 is what you're borrowing. What you're borrowing, that's the present value. 360 is a 30-year mortgage. 4.25% will become the interest rate. You've already set it for 12 payments per year. You don't do anything else. Hit the payment key, and it's $1377.43. $1377.43. Now, a couple things. If the problem gives you the payment, you still need to do this problem if you're trying to figure out how much interest or anything else. They might give you all the information. You still have to do the problem because it's a trick question. Now it says hit the one input 12. That you're taking that answer, 1377.43, you're entering that answer into the next problem. The reason you're saying 12 is because it's saying what will you have paid in interest and what would be his principal at the end of the first year. That's 12 months. Hit the gold key, and then under future value it says AMORT, and you should see in the screen 1/12. Hit the equal sign at 4720.42. That is the amount of principal you paid. Hit the equal sign again. It's going to show how much interest you paid of $11,000. And it's going to show you what your remaining balance is as a positive number of $275. Please make sure you know how to do net present value, internal rate of return, and the amortization problem. Go back to Unit 1 and use the workbook. Go back to Unit 2 and do the college funding calculation. I am going to be online early on Monday. I will be there no later than 5 o'clock, probably earlier. If you have any questions, please feel free to email me. And I am going to start with some time value of money problems before we get into the next unit. Again, I apologize for the technical problems on Wednesday evening. But this will make sure you have the information. I did break it up into 4 sessions because I was asked to, and therefore we concluded tonight's lecture. Thank you very much. And as always, you can email me, mktbear@yahoo.com, or call me, 847-498-1840. Leave me a message, and my goal is to respond to you within 24 hours during the week and to the best of my ability on the weekends. Thank you very much. See you Monday.